Hello, this is the last topic of polynomial functions, and it is writing equations of polynomial functions. Okay, so we have this graph, and we want to write the characteristics. We're talking about the roots, y-intercepts, degree of the polynomial, and end behavior. So for the roots, we just look at what the x-intercepts are. Same thing, roots, x-intercepts, zeros, those all mean the same thing. So we have -3, -1, and 2. Y-intercept, where it's crossing the y-axis, 3. The degree of the polynomial must be 3 because there were 3 roots. The degree of the polynomial and the number of roots that it has should match. And then the end behavior is what's going on at the ends of the function. So as we're going to the left, as x is getting bigger and bigger, so I'm going to write as x approaches infinity, the function's pointing down on that side. F of x approaches negative infinity. And then as we go to the left, so as x is getting smaller and smaller toward negative infinity, the function on that side is pointing up. As x approaches negative infinity, the function is approaching positive infinity. All right, so now we want to write the equation of that polynomial. And I'm just going to rewrite the roots and the information that we know. The roots were -3, -1, and 2. And then the y-intercept was 3. And it looked like this. That was the end behavior. It was pointing down on the right and up on the left. So we would start by writing the factors. Since 3 was a root, that means x plus 3 must have been a factor. So we're just working backwards. If x plus 3 is a factor, when you set that equal to 0 and solve for x, you get -3. So I'm just working backwards. If x equals -3, that means x plus 3 must have been a factor. So if -1 was a root, x plus 1 is a factor. And then if 2 was a root, x minus 2 was a factor. There could also be an a value in front that we don't know, and the way we figure that out is this other information that we're given. 2 pieces of information. One, that the y-intercept is 3, and that means when x is 0, the output is 3. So it's giving us a point that we could plug in and figure out what the a value is. This is an x and y coordinate. We can plug in these numbers for x and y and be able to solve for a. And also that the end behavior was pointing down on the right and up on the left. So once we get our final equation, we want to make sure that it matches that end behavior. So I'm just going to put a y equals in front of this, and then I'm going to go ahead and plug in my point here for x and y. So y is 3, and we need to use this information. The point of doing this is we're going to figure out what the a value is. I'm plugging in 0 for x. And then I'm going to simplify. This is a times 3 times 1 times -2. 3 times 1 times -2 is -6. So a times -6, I'm just going to rewrite as -6a. And then I still want to solve for a, so I'm going to divide both sides by -6. -1/2 is a. And that makes sense for this end behavior. If the a value is negative, and our degree is 3, we have 3 factors being multiplied together, then this is what the end behavior would look like. So I'm going to write out, I'm just going to leave it in factored form for this first one. -1/2 is the a value. The factors are x plus 3, x plus 1, x minus 2. So we're going to keep trying the same thing. Sometimes we're given a y-intercept, sometimes we're given some other information, and we always start with writing out what the factors are given some sort of roots or x-intercepts. And these ones we want to start writing in standard form. The last one I left in factored form. Standard form is when it's all multiplied out, we have separate terms, and they're in order from highest degree to lowest degree. Okay, so we have x-intercepts. So I'm going to go ahead and start writing what the factors would be. Just like with the last one, roots, x-intercepts, those will give us, we can work backwards and those will give us the factors. So if an x-intercept is -2, that means x plus 2 is a factor. If we have an x-intercept of -1, x plus 1 is a factor. And then if we have an x-intercept of +1, x minus 1 is a factor. It says a leading coefficient of 1. So we don't even need to find the a value. It's saying that's just 1 in the front. So different from the last problem where we had to figure out the a value because it was going through a specific y-intercept. We don't have to do that for this because it's not giving us that extra information. It just says leave the leading coefficient as 1. We don't have to solve for it. But we do need to write all of this in standard form. So I'm going to go ahead and multiply these first two factors together. We just want to multiply it all out. I'm starting with the first two factors, and then once I get that, I'm going to multiply to the third factor, the x minus 1. So just these two is x squared plus 3x plus 2, and we still want to multiply to x minus 1. So I'm just combining like terms, x cubed, oops, positive 2x squared minus x, and that was a -2, so minus 2. So make sure, standard form, you're multiplying it out. This just had a leading coefficient of 1, it told us, so we didn't have to figure out what the a value was. It just is 1. Okay, so same idea for this one. We were going to write it in standard form. We're given some slightly different information, but we're always given the roots or the zeros. This one has a degree of 4, and then instead of giving us a certain y-intercept or point, it's telling us that the leading coefficient is just going to be -2. So that's the a value. We don't have to solve for a like we did in the last one. It's just telling us it's -2. All right, so we always start with the zeros or the roots. Remember, zeros, roots, that means same thing. Roots, x-intercepts. So 2i is a root. I'm going to start to piece together the factors. This one's a little weird though, because if 2i is a root, x minus 2i is a factor. But in order, think about how we would have to get 2i as a solution, as a root. That meant we had to have taken a square root. We had to take a square root of -4 in order to get this, if we took the square root of that on both sides to solve, we would get square root of -4 is 2i. Actually, it's plus or minus 2i. So if 2i is a 0, that means it's not telling us. We have to kind of figure it out that -2i is another 0. And if -2i is a 0, x plus 2i is a factor. If 4 is a 0, x minus 4 is a factor, and if 0 is a 0, then it would just be x minus 0, just x for the other factor. And because it says the leading coefficient is -2, I'm going to throw a -2 in front. Let me go back to this real quick. Anytime there's a 0 that has an I in it, which came from taking a square root, or if there's a 0 that just had a square root in it, the opposite of that number, that value, would also be a root. So for example, say it said one of the roots was square root of 3. That means we just know that negative square root of 3 would also be a root, because in order to get that root, you had to take a square root, and whenever you take a square root when you're solving, you need a plus or minus in front. If, let's say, 5i, or let's say -5i was a root, then that means 5i would also be a root. Say you're solving with quadratic formula and one of the solutions or roots was 2 minus 2 root 3. Then that means 2 plus 2 root 3 would also be a root. These are called conjugates. Just the idea that you have like the opposite sign here in front of the root, the root part. One's positive, one's negative. That's called the conjugate. All right, now we want it in standard form, so we're going to multiply it all out. And then we also want to double check once we get our answer that the degree should be 4. So the term with the highest power should be x to the fourth. It should have a fourth power in it. So we can multiply in any order that we want. I'm going to go ahead and just, actually I'm not going to do it in the order that's there. Anytime you have i's or radicals in the factors, you want to multiply those first, because the i's or radicals will end up canceling out, and then you won't have any more i's or radicals that you have to deal with and carry through the rest of the problem and try to multiply together. So I'm doing x minus 2i times x plus 2i. And I'm going to do the area model so we can kind of organize all the parts, all the terms. So x minus 2i times x plus 2i. And if we do x times x, x squared, x times negative 2i is negative 2xi. And then x times positive 2i is positive 2xi. Negative 2i times positive 2i, negative 4i squared. And just remember what I is. I is the square root of negative 1. So that would mean that I squared is just negative 1. So anytime you have an I squared, when you're simplifying, that equals negative 1. Negative 4 times I squared, which is negative 1, is just positive 4. These two terms cancel out, so we end up with x squared plus 4. There's still negative 2 in front, x minus 4 times an x. So now, again, I could multiply in any order that I want. I'm going to go ahead and do these first two, negative 2x squared minus 8, and there's still x minus 4 times x. And then I'm going to multiply these two together. I'm going to erase some stuff on the side so we can make room, because I want to do the area model again. So I'm just doing the area model so that I'm keeping track of all the terms. It's actually positive 32, and I'm going to write out, now I have negative 2x cubed. There's actually no like terms in this, so 8x squared minus 8x plus 32. And finally, I still have times this x I haven't multiplied by. So I'm just going to distribute the x to all those terms, and my final answer for this function would be negative 2x. Remember, I'm multiplying, I'm distributing this x to all of these terms. I need to multiply that out. So negative 2x to the fourth, 8x cubed, minus 8x squared, plus 32x. And the reason I had to multiply that all out was because it said to write it in standard form. If it doesn't say that, then you would just leave it in factored form like this, or even better, like this, because we multiplied with the i's, the parts with the i's together, so we didn't have any i's in our factors. Okay, so same idea. Again, we want to write it in standard form. I'm going to start with the roots, or the x-intercepts. So if negative 1/2 is a root, that means x plus 1/2 is a factor. If 1 is a root, or an x-intercept, or 0, x minus 1 is a factor. It says it has multiplicity of 2. That means there are 2 of them. So I can either write out both factors, or I could just say x minus 1 squared and then not write it out twice. It's the same thing either way. There is an a value that we don't know, and the way we get that a value is by plugging in this point for x and y. So I'm going to plug in negative 12 for y, and I want to figure out what the a value is, plugging in negative 1 for x. And then I'm going to simplify so that I can solve for a. Negative 1 plus 1/2 is negative 1/2. Negative 1 minus 1 is negative 2, and then I'm going to need to square that. Negative 2 squared is positive 4. And positive 4 times negative 1/2 is negative 2. So this right side would be a times negative 2, or negative 2a. Divide by negative 2, so we can get the a. A is 6. Still need to write the whole thing out in standard form. But now I can plug in what I got for a. 6, and then I'm going to write the factors and multiply this out. I'm going to multiply these next. 6x plus 3 if I distribute the 6. And then I still have x minus 1 squared, which is x minus 1 times x minus 1. I'm going to go ahead and multiply that out next, x minus 1 times x minus 1. So I'm going to multiply 6x plus 3 times x squared minus 2x plus 1. I'm going to do the area model again just to organize it all. And I'm going to combine like terms. So now I have my final answer, 6x cubed minus 9x squared. These will cancel out, plus 3. Same thing, standard form, start with the factors. Okay, so I wrote out the factors that would give me those x-intercepts. If the y-intercept is negative 6, that means it goes through the point 0, negative 6. So I'm just writing the y-intercept as a coordinate. And then like the last problem, we need to plug in that point so that we can figure out what this a value is. So I'm plugging in negative 6 for y, 0 for x, so we can solve for a. And then I'm going to simplify. 1 times negative 3 times negative 4, that's 12. 8 times 12, I'm going to write as 12a. A is negative 1/2. I still need to write it all in standard form, which means put the a back in and multiply it all out. I'm just going to leave the negative 1/2 in front for now and just start multiplying the binomials together, and then at the end, once I multiply these three factors, these three binomials, then I'll multiply everything by negative 1/2. So x plus 1 times x minus 3, it's going to be x squared minus 2x minus 3. You could do the area model, the boxes, to get that. And then I'm going to multiply that times x minus 4. And then finally, I'm going to multiply by negative 1/2 at the end. So now I'm multiplying these two together. Okay, so I went ahead and just filled in the area model for multiplying x squared minus 2x minus 3 and x minus 4. I still have the negative 1/2 in front, but now I have x cubed, just combining like terms here, negative 4x and negative 2x minus 6x squared, negative 3x and 8x plus 5x, and then plus 12. And I'm going to go ahead and distribute the negative 1/2. So negative 1/2 x cubed plus, I have negative 1/2 times negative 6, 3x squared, minus 1/2 times 5, I'm going to put 5 over 2x, and negative 1/2 times 12, minus 6. All right, another example, degree of 4. Zeros, 5, 0, and -1 with a multiplicity of 2. Leading coefficient, that's the a value, is 3. I'm going to go ahead and write the factors. So I have x minus 5. If 0 is a 0, then the factor would just be x, or x minus 0 is just x. I went ahead and put that in the front. I think it looks better in the front when you have just the x by itself. And then x plus 1 squared because it says multiplicity of 2. Leading coefficient is 3. I'll throw a 3 in front. And then we just have to multiply it out, put it in standard form. I'm going to multiply these two together. And I'm going to go ahead and also multiply out x plus 1 squared. That means x plus 1 times another x plus 1. You could do that in your head, or the area model, x squared plus 2x plus 1. And then now I can multiply these together. I'm going to use the area model. And I'm just going to combine like terms and write out my final answer for this function. It would be 3x to the 4th minus 9x cubed minus 27x squared minus 15x. Okay, I'm going to write the factors. And this one we're giving another weird one where we have root 3 is a 0, so that means x minus root 3 is a factor. But what I was saying earlier about square roots, or i's for the zeros, in order to get that 0, a square root had to have been taken, and when you take a square root when you're solving, there's a plus or minus. So if root 3 is a 0, negative root 3 must be another 0. And if negative root 3 is a 0, x plus root 3 is a factor. We also have 6 with a multiplicity of 2. So x minus 6, there's 2 of them, another x minus 6. So I'm going to put squared on it. The end behavior, it's saying on the right side it's going up, on the left side is also going up. I'm going to go ahead and multiply out what I have and then just double check that that is the end behavior at the end. That end behavior occurs when it is an even degree and a positive leading coefficient. So I want to make sure I get that at the end. Whenever we have factors with roots or i's, we want to multiply those together first. So I'm going to use the area model to organize my terms. So we have x times x, x squared, x times negative root 3, negative x root 3, x times positive root 3, positive x root 3, so those terms will cancel out, they're opposites of each other. And then negative root 3 times root 3, negative. Square root of 3 times square root of 3 is square root of 9, which is just 3. So negative 3 would be in that box. These canceled, so x squared minus 3. And we want to multiply that times x minus 6 squared. I'm going to do x minus 6 times x minus 6, x squared minus 12x plus 36. And then finally multiplying these two together. Okay, so I filled in all those boxes and I'm going to combine everything to get our final answer. X to the 4th. So I am getting an even degree and a positive leading coefficient. So I don't need to change anything. This matches this correct end behavior. I'm looking for the cubic terms. There's a negative 12x cubed. So I've got that one, that one, that one. I have a negative 3x squared and a 36x squared. So 33x squared. And then a 36x and negative 108, minus 108.